2016 AMC12A Question 5. Goldbach's conjecture states that every even integer greater than 2 can be written as the sum of two prime numbers. For example, 2016 equals 13 plus 2003. So far, no one has been able to prove that the conjecture is true, and no one has found a counterexample to show that the conjecture is false. What would a counterexample consist of? So in this one, it's just a structure of mathematics, a pure mathematics. What is a counterexample? So a counterexample is something that shows that this right here, every even integer greater than 2 can be written as the sum of two prime numbers, is false. So we have like a statement. If we have an even integer greater than 2, I'll call that p, then it can be written as the sum of two primes. And our statement is p implies q. The only way to make this, so only way to make this false is if the p is true, but the q is not true. It's this if then. If the p isn't true, then it doesn't matter what happens over here. So I'm going to look for a case where I have an integer greater than 2. So I want an integer x greater than 2, even integer. And I want to show or find one that is not the sum of two primes. So let's go through the list. An odd integer. No, I need it to be an even integer to possibly make this thing false. An odd integer. No. An even integer greater than 2. That's good. That can be written as the sum of two prime. No. I even cut off some stuff, but no. An even integer greater than 2 that can be written as the sum of two prime numbers. No. An even integer greater than 2 that cannot be written as the sum of two primes. Yes, this is the counterexample to this. I have the same hypothesis, but the opposite conclusion. Feel free to comment with questions down below.